Hello and welcome to today's video about subtracting mixed numbers. First, let's talk about subtracting mixed numbers with no renaming. The first problem we are going to look at is 3 3/4 minus 1 1/4. You will notice in looking at this problem that we do not need to do any renaming or borrowing for the fractional parts. This type of problem is relatively easy. We are simply going to subtract 3/4 and 1/4, which is 2/4, and then 3 minus 1, which are our whole numbers, that equals 2. And we're going to simplify this problem down. 2 will stay the same because it's a whole number and it doesn't need to change. But as you know, 2/4 is the same thing as 1/2. So we'll simplify it to that. Our final answer for 3 3/4 minus 1 1/4 is 2 1/2. Before we move on, let's look at one more problem. This problem reads 7 5/6 minus 2 2/6. Again, we don't need to do any renaming or any borrowing to make the top fraction bigger than the bottom one, because it already is. So we are just going to subtract straight down. 5/6 minus 2/6 is the same thing as 3/6, and 7 minus 2 is the same thing as 5. Then we're going to simplify 5 and 3/6 down. And 3/6, since 3 is half of 6, the same 3/6 equals 1/2. So our final answer is going to be 5 1/2. Before we move on to subtracting mixed numbers where renaming will be necessary, we are going to first look at how to rename mixed numbers in general. Let's look at this mixed number first, 2 1/9. I am going to rename 2 1/9 by taking a whole away from the 2 and moving it over to my fractional part. If I take one whole away from 2, I am left with 1. Within the realm of fractions, one whole is equal to 9/9 in this case. And I want to move that over to this fraction, but keep in mind what this initial fraction says when finding my final answer. Remember that both sides still have to be equal, which means they still have to have the same amount on both sides. If I take 9/9 away from this 2 and add it to this fraction right here, I am going to come up with 10/9. So the number that I'm replacing up top in the numerator is 10, because 1/9, which is this fraction, plus 9/9 equals 10/9. So 2 1/9 is the same thing as 1 10/9. Now let's look at this mixed number. 6 3/7 equals blank and 10/7. We need to figure out what whole number needs to go here by subtracting the smaller fraction from the larger fraction. In this case, we have 10/7 minus 3/7 is going to equal 7/7. As you can see, I have 7/7 left over, and 7/7 is the same thing as one whole. I can draw the conclusion that I took 7/7 or one whole from this 6 to move it over to the fractional part of this mixed number. If I took one whole away, that's the same thing as saying 6 minus 1, which is equal to 5. So my final answer is 5 10/7. Now let's finally talk about the biggest and most difficult part of this lesson, which is subtracting mixed numbers with renaming. Here is the first problem we are going to work with. This problem reads 3 1/3 minus 1 2/3. When looking at this problem, you may not initially see an issue. After all, 3 minus 1 is completely doable without causing a negative number. However, when you look at the fractional parts of this problem, you will see that 1/3 is smaller than 2/3. What we can't do in this situation is simply flip the two fractions so that it reads 3 2/3 minus 1 1/3. This would change the entire meaning of the problem. What we need to do instead is rename or borrow from a whole number to create a fractional part on the top part of the problem that is bigger than the fractional part on the bottom part of the problem. This is why we went over renaming numbers without the subtraction piece in the last slide. The first thing I'm going to do in this problem is put in some equal signs. I'm going to carry over 1 2/3 because that does not need to change. The one that we're changing is the 3 1/3. I am going to borrow 1 whole, or 3/3, from the 3 to make the 3 a 2. When I borrow 3/3 from the 3, I need to add those into my fractional part. So 3/3 plus 1/3 is the same thing as 4/3. Now I've created an equivalent mixed number to 3 1/3 by borrowing 1 whole from the 3, adding it to the fractional part of 1/3, and I've created 2 4/3 as the usable mixed number that I'm going to subtract. My next step is now to just subtract top to bottom. I'm going to start with the fractional parts because I like going right to left with these problems. 4/3 minus 2/3 is the same thing as 2/3, and 2 minus 1 is the same thing as 1. 2 and 3 are both prime numbers. They don't have any multiples that are, or any factors that are the same, so we can't simplify this anymore. Our final answer is going to read 1 2/3. Now let's look at this problem. This problem reads 8 minus 3 2/3. At first glance, some 5th graders might think that it's totally okay to just subtract the two whole numbers, 8 minus 3, which is 5, and write the fractional part at the bottom, making our answer 5 2/3. This, however, is not the way to go about solving this problem. Technically, what I have up top next to that 8 is 0/3. I don't write that because, as you know, every whole number technically has a decimal at the end of it, followed by zeros that go on forever. We don't write that because we don't need to. We understand that those are there, but know that we don't need to express them every time we write a number. This is the same thing. So the first thing I need to do in this problem, as I've done in the past, is borrow from the 8. I'm going to borrow 1 whole, which is going to make it a 7. And I'm borrowing a full 3/3 because that's equal to 1. So 7 3/3 is the same thing as 8. I'm also going to go ahead and move this second fraction over. And I'm not going to change it at all because it's the bottom number. It doesn't need to have any changes made before it can be subtracted. Now I can subtract these two numbers, 7 3/3 minus 2 2/3, and I am going to end up with this. 3/3 minus 2/3 is the same thing as 1/3. 7 minus 3 is the same thing as 4, and since 1 and 3 are both in the smallest form they can be in because they're both prime numbers, I am going to come up with a final answer of 4 1/3. Now let's look at one last problem. This problem reads 3 1/3 minus 1 1/2. Upon looking at these two mixed numbers, you will notice right away that they have different fractional parts, meaning their denominators are different numbers. The first thing we have to do in this problem is make a change so that both of them have matching denominators before we can try to subtract anything. I am going to use the method of quick common denominators by multiplying the top and the bottom by the opposite denominator. So 1 1/2, I'm going to multiply the top and the bottom of the half part by 3, and with the 3 1/3 mixed number, I'm going to multiply 1/3, top and bottom, by 2. I'm going to come up with these new fractions. 3 stays the same because it's my whole number, but 1 times 2 is 2, and 3 times 2 is 6. Again, 1 stays the same because it's our whole number, but 1 times 3 is 3, and 2 times 3 is also 6. Now in looking at this problem, you will notice that I have not completed all of the steps that I need to complete. I cannot do 2/6 minus 3/6 because 2/6 is smaller than 3/6. So the next thing I have to do is rename or borrow from the 3 by taking out 6/6 and creating a 2. When I take 6/6 away from 3, I am going to add that 6/6 into the 2/6, and I'm going to come up with 8/6 because 6 plus 2 is 8. 1 3/6 does not need to change. My final step is to simply do my subtraction. So 8 minus 3 is 5, and I carry the denominator down, and 2 minus 1 is 1. So my final answer for 3 1/3 minus 1 1/2 is 1 5/6. Here are your practice problems of the day. First, solve this problem. 6 minus 3 1/4. Don't forget to rename where you need to. Remember that you can't just subtract 6 minus 3 and carry 1/4 down to the bottom. You have to rename 6 so it creates an equivalent mixed number that is still equal to 6 but reads differently. Next, subtract the mixed numbers 8 and 1/4 minus 7 and 2/3. Don't forget to create common denominators first, then borrow if you need to, and finally solve the problem and write it in simplest terms. Good luck!